All right, so here we go. I'm going to roll right into the next lesson, which is reference angles and exact values. It's more or less a review of the last 4 lessons that we did. If you watched the last ones, don't think that I'm wearing the same clothes every day. I'm just doing the same lesson right after the other. All right, so here we go. Sketch and label theta in standard position if theta equals 7 pi over 6. So theta, remember, is an angle. So if you're going to draw the angle, 0, 90, 180, 270, well, where is that? So this is measured here in radians. So what I want to do is I want to convert that into degrees. And to do that, radians to degrees, you multiply it by 180 over pi. Okay, the pi's end up canceling out. So 7 times 180 divided by 6 is 210 degrees. And if you're going to do that, so here's 90, 180, and then so 210 is going to lie somewhere down right over here, and you are there in the third quadrant. All right, so there's converting your radians to degrees. Okay, now figuring out where that is based on whether the function is positive or negative. That's this here. We remember the acronym of all students take calculus. So the sine function is less than 0, which means he's negative. The tangent function is greater than 0, which means he is positive. So where is the tangent positive? The tangent's positive here and here. But the sine would have to be negative, so he can't be here because sine's positive there. So we are sitting in the third quadrant. All right. Okay, so the next review thing we have is of reference angles, and that is an acute angle formed by the terminal side. Remember, terminal side is just when you draw an angle where the angle ended. Okay, so this would be considered the terminal side. And the x-axis. So the angle, the acute angle made from the terminal side and the x-axis, and that would be right there. That's a reference angle. Okay, so these guys are showing you that there are no reference angles at 0, 90, 180, 270, and 360. And then here you're taking a look at where the reference angle lie in the 4 quadrants. So here's an angle of 60 degrees, so his reference angle is 60 degrees. Here's an angle of 120 degrees, so the reference angle is over here now, and he's 60 degrees. If I drew an angle of 240 degrees, then the reference angle is going to be drawn here. There's your x-axis. That's 60 degrees. And then here's an angle of 315 degrees. And then that is going to be the reference angle, and he's going to be 45 degrees. All right, so there's a little review for you on using the reference angle. Then we have the memorized unit circle. And if you don't, then you should. And remember, the only one you really need to memorize is this guy up here, because then over here, just the x values change. Then when you move down, the x values stay the same as your negative, and now you're going to change his y values. And then moving over in this direction here, your x values stayed the same, and the y values became negative. That's kind of the easiest way to memorize it. And if you really don't want to memorize it, but you'd rather just remember the 2 special 45, 45, 90 triangle and the 30, 60, 90 triangle, remember the 45, 45, 90 has legs of 1 and a hypotenuse of radical 2. And the 30, 60, 90, opposite of the 30 is 1, opposite of the 60 is radical 3, and opposite of the 90 degrees is 2. So they're saying, well, how did these coordinates come to play, right? So I can't see it. Okay, maybe you can on your paper. Basically, okay, let's take the first point here, and that point was at 30 degrees, right? So that means right here would be 30 degrees. I'm going to transcribe that triangle. 30 here, so here's going to be radical 3. Here's going to be opposite of that is 1, and then here's going to be 2. So this right here is the x, right? So it wants to know, what is this x distance? And if you're looking at at x is considered the cosine, right? X is cosine on the unit circle. Cosine is adjacent over hypotenuse. In this case would be radical 3 over 2. And if I'm right, see right here, that distance there is radical 3 over 2. Now to find the y value, y is sine. So again, here's another review. Remember, cosine is x, and the sine is the y. Well, sine is opposite over hypotenuse, so the opposite is 1, and the hypotenuse is 2, and that's where they got 1 over 2. And then the same thing happens for 45 and 60. So that's kind of where it all comes from there. All right, so now let's take a look at these three angles drawn. Okay, what do you notice about the points located at angle 30, 150, 210, and 330? Well, all of the points have this radical 3 over 2 1/2, radical 3 over 2 1/2, radical 3 over 2 1/2, except one of the signs are changing, right? So what do you think is happening? Well, they're drawing the same angle. Well, what do you mean they're drawing the same angle? Okay, these kind of mix together. Look at those points. Look at where they are, right? Take a look at their reference angles, right? They all share the same reference angle. Okay, all share same reference angle of 30 degrees. So in all of these, they're all using that 30, 60, 90 triangle to find the opposite hypotenuse and adjacent hypotenuse. And then it's the same thing here. Well, what do you notice at 45, 135, 225, and 315? They're all going to have the same reference angle at 45 degrees. Reference angle of 45 degrees. And all of the 45 degree points are radical 2 over 2. And again, just your sign is changing. Right, so there's kind of your rundown a little bit on your unit circle. Then there's this handy chart, which again, it's kind of all tying back into that unit circle. Okay, sine 30, cosine 30, tangent 30. Okay, but just actually looking at the individual y over x. And here's 1/2. Here's radical 3 over 2. Here was radical 3 over 3. This is radical 2 over 2. Your radical 2 over 2, and your 1. Radical 3 over 2, 1/2, and radical 3. And again, if you memorize, take a look. These are basically where they're getting, well, I should say sine and cosine. That is where you're getting it. Okay, these are that's where these points are coming from. All right. Okay, and then our final little activity here. They want you to find the exact value at any angle. So they want you to sketch the angle, determine the reference angle, calculate the trig function of the reference angle, determine if the function is positive or negative. So it's kind of rolling everybody all into one. So let's go ahead and do that. Let's start with a nice warm-up one at 150 degrees. Right? So if I'm going to sketch 150 degrees, we know that over here is 180. So right over there, that's going to be 150 degrees. That means that, okay, if I'm going to complete that, that means that the reference angle here is going to be 30 degrees. Okay, none of this is going to work with an ugly picture like that. Let me get a little bit neater here. Oh, jeez. Terrible. Okay, I'll make it a little, there, that's a little bit better. There's that angle of 150 degrees. That created a reference angle of 30 degrees, right? So finding the exact value of where that is. So if that is a 30, 60, 90 triangle, okay, if you memorize what that one was, opposite of the 60 is radical 3. Opposite of the 30 is the 1, and the hypotenuse is 2. So what they want here is the sine function. Sine is talking about the y, right? So this is going to be the opposite over hypotenuse. So the opposite is 1, the hypotenuse is 2, so that's going to be 1 over 2. Now, is this value going to be positive or negative? All students take calculus. Sine is positive. There you go. All right, let's try another one. Now, what do we call this? what do we call 5 pi over 6? That is not a degree, it is a radian. So let's convert that by doing 180 over pi, cancel out the pi's. 5 6 times 180 is 150. Oh, good, easy, because I did that already. It's going to be the same thing. It's going to be 150 degrees. They just wrote it a different way. This is going to be 30. We're going to find the exact value of it. So that means you're going to do 30, 60, 90. Hypotenuse is 2. Opposite of the 30 is that. That's going to be radical 3. So now they want tangent. Okay, think back. What do we call the tangent? Tangent is like having the y over x, right? So what we're going to do, tangent is opposite over adjacent. So the opposite side is 1. The adjacent side is radical 3. So this is going to be 1 over radical 3. Now, you have to simplify this. Remember, we have to rationalize that because we're not allowed to have that there. So that's going to be radical 3 over 3, because 3 times 3 is 9. The square root of 9 is 3. Now, we are in the second quadrant. Is the tangent positive? No. So it's going to be negative radical 3 over 3, and that's going to be your value there. Okay? Negative radical 3 over 3 is the exact value of the trig function. All right, so let's do here, let's go into some inverse functions. The cosecant of negative 135 degrees. All right, so that means if I'm going negative, that means I'm moving in this direction. Okay, so you got to go past 90 and into here. That's going to be 135 there. Now I'm going to need his reference angle. Okay, you can look at it this way. If that way was going negative 135, how much did I go in this direction? If you don't like negatives, and you could just add 360 to that, and that's going to give you 225. Now, let's figure out which triangle we're using. That right there, that's going to be 45 degrees. So you're going to be using the 45, 45, 90, which is the leg's going to be 1. The hypotenuse is going to be 2. Now, cosecant comes from sine. So here's how I like to do it. Okay, I'll just find sine. So sine is opposite over hypotenuse, which is 1 over radical 2, right? Now, since they said cosecant, it's an inverse function, reciprocal that, and there's your answer. So if I reciprocal that, I just moved in, that's going to be radical 2 over 1. Now, is that positive or negative, right? So since it's the sine, and you're in the, where am I? I'm in the third quadrant here. The third quadrant belongs to tangent. Since I'm not the tangent, I'm the sine, cosecant. So the final answer is going to be negative radical 2. All right? All right, D kind of takes into consideration changing the degrees. So if you, oh boy. So if you want, you can try to hit pause and try and figure out how to find the degree measure, then come back, and then we can go from there. Cancel this guy out. And this is going to give me a nice, it looks like 300 degrees, right? So if I'm going to draw that picture and I'm going to draw 300 degrees, it goes around there. So there's my 300. If I went to 300, which triangle am I using? Well, my reference angle is going to be 60 degrees. So you're going to be using that 30, 60, 90 triangle again. So opposite of the 60 is 1, the hypotenuse is 2, and over here is going to be radical 3. Now they want the cotangent. The cotangent came from the tangent, which is opposite over adjacent. The opposite is 1, the adjacent is radical 3. So that's 1 over radical 3. Now since it was cotangent, flip them, right? So that's going to become radical 3 over 1, right? So let's now, I'm going to write the answer right here. Radical 3. they're using the tangent function. Okay, they're using the tangent function, which means that you are all students. Take, calculate. You belong to the cosine, so tangent is going to be negative. Radical 3 is going to be my final answer there. Okay, there you go there. Hopefully that worked good there. Next one, cosine 675. So you're going to be going around and around a couple times here. Okay, the first time would be 360, right? Okay, so you run around, you run to 360. Then you got to go around how much more? And you're going to be going around 315 degrees more. Okay, so there you are there. We're back in that fourth quadrant again. So if I went around for 315, I'm going to be left with 45 as my reference angle. That's the triangle I'm using. So that's going to be a 1, and a radical 2. And then, okay, we're using cosine, which is adjacent over hypotenuse. The adjacent side is 1, and here it's radical 2. Now, you cannot leave that there, okay, and nor am I flipping this one because it's not an inverse. So you're going to be left with a radical 2 over 2. And now, because you are a cosine, you are positive because you're in the fourth quadrant, so there's your final answer, radical 2. Last but not least, secant, we're going negative 240. So here we go. Here's 90, here's 180, and then 240 is going to be over here, right? So that's how you move negative 240. That's going to be then 60 is going to be what's left, okay? Because you hit that 180 mark to get to 240, 60 left. 30 and 90, which means you're 2. Opposite of the 60 is radical 3, and then you're going to be 1. Okay? Now, what they want? They wanted secant. Secant comes from cosine. Cosine is opposite over hypotenuse. No, it's not. It's adjacent over hypotenuse. So the adjacent side is 1. The hypotenuse side is 2. So that's 1 over 2. But since they wanted his inverse, you're going to be flipping it. So instead of 1 over 2, it's 2 over 1. Is that 2 over 1 going to be positive or negative? We are in the second quadrant. Second belongs to sine. We are cosine, so that's going to be a negative value. All right, so hopefully this whole unit worked for you guys. If you're just watching this one, there's 4 other videos that go over unit circle, cofunctions, reference angles, and all the stuff that we looked at here today. Hopefully this helped, and if you liked it, give a thumbs up, subscribe, whatever it is you guys do.